Hello, definition of an ellipse. No, not an ellipse, all right? An ellipse is basically a set of points in a plane whose distance is fixed from two foci. Now, each point is a focus. The two foci are plural. And we also have what we call vertices and major axes here. The vertices occur at the ends, and notice the end of the major axis, which is in this particular one's horizontal. The minor one is vertical, but it doesn't have to be that way. I'll talk about that in a minute. And notice that our distance, when we add D1 and D2, is constant. Doesn't mean D1 equals D2, but as we move around the circles, kind of like an ellipse forms by putting two little tacks with a string around it, and you take a point, and as far as your string can reach, that's where the ellipse makes. Okay? So their standard form of the equation is this here. If the center of the ellipse is HK, the distance from the center to the major axis vertices is A. The distance to the minor one is called B, the blue there. C is the distance from the foci to the center. So then if that's the case, if you think of this here, that's B squared, that's C squared. B squared plus C squared will be in square rooted. That will give me the distance, in a sense, from our point to right there. Right, especially like right up there at that particular point. And we know this here, that seeing how that no matter where we move that, that's our total distance. D1 and D2 equal each other. So here's the thing, if that's A and that's right here, and we take the A plus that C right there, this is from that foci, and we take the A and minus the C, this is from here to there, we actually can find out these two things equal. And when we add these together, C's cancel, so I have 2A divided by 2. So A is equal to B squared plus C squared. If I squared them, A squared would equal B squared plus C squared. Yay! Then also what would be true is B squared would equal A squared minus C squared. It's not written up there. And C squared would equal A squared minus B squared. And hence we put all that together and we end up with the formula for an ellipse. Here's the formula for the ellipse. All right, which basically takes it's the center of the, well, kind of like your circle, but your ellipse, divided by, that's your major axis and minor axis. Now, I want to talk about that here because A is always the major, because when you write these out, the B is always smaller than A, and they're always positive. Notice, because they're all larger than 0, they're positive. So here's what we know. If A is always larger and it's underneath the X, the major axis is horizontal. If A is underneath the Y's, the major axis is vertical because the A is always the larger one. And the same would be true here. Notice these to be the same values if we have the point 0, 0 at the origin, because the H and K would be 0, which wouldn't necessarily even needed to be there.